Okay, so this was question 8, and it was a coordinate geometry question where you had to plot the lines L, which is 3x minus y minus 3 is equal to 0, and k, which is x minus y plus 1 is equal to 0 on the graph above. So what we need to do is, for each line, let x equal 0, get an answer, let y equal 0, and get an answer. So let's start with L. So L is 3x minus y minus 3 is equal to 0. And we'll start by letting x equals 0. So when x equals 0, we get 3 times 0 minus y minus 3 is equal to 0, which leaves me with minus y minus 3 is equal to 0, which can be manipulated to say minus y is equal to 3 or y is equal to minus 3. So 1 point on this line, and I'll use purple because I've written in purple. So the first point, when x is 0, y is minus 3, which is there. Okay. And when y is 0, what do we get? We get 3x minus 0 minus 3 is equal to 0. 3x minus 3 is equal to 0. 3x is equal to 3, x is equal to 1. So when x is equal to 0, or sorry, when y is equal to 0, x is equal to 1, which is there. So you draw a line. So you can't see it, but I have a kind of makeshift ruler to do this. There we go. So that's the best I can get at the moment. Okay, so that's our first line plotted for L. All right, so let's go for K. All right, so K is x minus y plus 1 is equal to 0. So we're going to let x equal 0, which will give me minus y plus 1 is equal to 0. Excuse me, minus y is equal to minus 1, or y is equal to 1. If I let y equal 0, I get x plus 1 is equal to 0, x is equal to minus 1. All right, so plotting those points in the line, when x is 0, y is 1. So 0 on the x-axis, 1 on the y-axis. And when y is 0, x is minus 1. So when y is 0, x is... Okay, so sorry, when y is 0, x is equal to minus 1, which is there. And when you draw the line connecting the two together, so you can't see it, but I have a ruler here, which is this. And we can see there is some point of intersection around here, okay? But we'll have to verify that algebraically in this question.